Okay, so now that we've looked at our definitions related to probability, we can try an actual example. So, example 1, you're off to soccer and love being the goalkeeper, but that depends on who's coaching today. With Coach Sam, the probability of being goalkeeper is 0.5. That's basically 50%. With Coach Alex, the probability of being goalkeeper is 0.3, which is 30%. Sam is coached more often, about 6 out of every 10 games, a probability of 0.6, so you're just dividing 6 divided by 10 to get that number. What is the probability that you will be goalkeeper today? So we can use a tree diagram to figure this out. So our two options are Sam, or it can be Coach Alex. So what are our chances that it's Sam? It's 60%, so we'll write 0.6 here. With Alex, it would be 40%, right? Because they have to add up to 100%. So if Sam is coaching 60% of the time, that means Alex is coaching the remaining 40. If Sam is the coach, that means we have a 50% chance that he would let you be the goalkeeper. So I guess I'll put yes to goalkeeper here, and that's going to be 50%, so 0.5. So obviously the remaining 50% would be that you're not the goalkeeper if Sam is coaching, so 0.5 here. What about Alex? If Alex is coaching, 30% of the time you are goalkeeper when he's coaching, so yes to goalkeeper would be 30%. No would be the remaining 70%. So we just want to know what our probability of being a goalkeeper is. So we're just looking for the yeses. So according to our tree diagram, if we trace out the path to yes, it would be 60% to get to Sam, 50% to get to yes. Or alternatively, if it was Alex, you would go to Alex and then 30%. So this would give you if it's Sam, it would be 0.6 times 0.5, which would give you 0.3. So you have a 30% chance of being goalkeeper if the coach is Sam. What if it's Alex? It would be 0.4 times 0.3, which is 0.12, 12%. Let's do the others for fun. So now we're looking for the instances where you're not going to be goalkeeper. So your probability of if Sam is coaching would be 0.6 times 0.5, which is the same. And then if Alex is coaching, what are the chances you're not going to be goalkeepers? So 0.4 times 0.7, which is 0.28. So we just care about our probability of being the goalkeeper. So let's add up our yeses. So we have 0.3, it's a 30% chance when Sam is coach, and 0.12 when Alex is coach, and then that gives you 0.42, which is 42% chance of being goalie today. And now I want to do a quick check just to make sure this makes sense. Let's take all our scenarios. So I'm just going to take this value, this value, this value, this value, add them up. Those are all your cases. And make sure they add up to 100%, just for verification. So we have 0.3 plus 0.3, so those are Sam's scenarios, and 0.12 plus 0.28, and if you add those up, you'll get 1, which is equivalent to 100%. So when we're working with probabilities, we like to express our percentages in terms of decimals. So they're interchangeable, and you can convert one to the other. In the last example that we did, we used a tree diagram to calculate our probabilities. That's always an option, but it can be quite time-consuming. So there is an easier way to do it. Let's look at this theorem. If we have an event, which we can call it A, we want to figure out the probability of an event occurring. We would take the number of instances where A can occur, so the number of outcomes in which A can occur. We're going to divide that by the total number of outcomes, which is number of S. That's the total number of possible outcomes. Okay, let's do an example. So with a roll of 2 6-sided dice, what is the probability of rolling a total of 7? So a sum of 7. We need to define our event. That's the first thing. So our event, let's call it A, would be rolling a 7. Okay, now just because I moved the slide up, let's just bring back this formula. So probability of A occurring is going to be number of times that A occurs over total number of outcomes. And let's make a chart. So for my chart, I have the top row is going to be the first die, and then the column is going to be the second die. So we're going to take all our possible sums. So first scenario, we have 1 plus 1. That's going to give us a sum of 2. And then 1 plus 2 is going to give us 3, 4, 5, 6, 7. And then 2 plus 1 is going to be 3. 2 plus 2 is 4. 2 plus 3 is 5. You can see what the pattern is. 3 plus 1 is 4. 3 plus 2 is 5. And again, note the pattern. So 5, 6, 7, 8, 9, 10. 5 plus 1 is 6. 5 plus 2 is 7. 5 plus 3 is 8. 10, 11. 6 plus 1 is 7. And then 8, 9, 10, 11, and 6 plus 6 is 12. Okay, so I just want to highlight where event A, or rolling a 7, is occurring. So it's happening here, 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 here. You can see the pattern. There's like a nice diagonal. So now to calculate the probability, how many instances is this happening? So 1, 2, 3, 4, 5, 6. So 6 times. And we're rolling a, so these are all your possible outcomes. And how many possible outcomes are there? So 6 times 6 is 36. And you can reduce that to 1 out of 6, which gives you 0.17 or 17%. A useful and important concept in probability is the complement of an event. So the complement of an event is when event A does not happen. So whichever outcomes make up A, all the other outcomes would make up not A, or A prime. So this right here is the complement of A, and it's read as A prime or not A. So they're the same things. And so they always need to add up to 1, right? Because the probability of A happening plus the probability of A not happening are going to be all your possible outcomes and that's going to be 100%. So if we just rearrange this equation right here, if we want to figure out what the probability of not A happening is, it would just be 100%, or 1, minus the probability of A occurring. Okay, so let's do an example illustrating this. What is the probability that a randomly drawn integer between 1 and 40 is not a perfect square? Okay, so first thing we want to do is define our event A. So A would be a perfect square. And then not A would be obviously not a perfect square. Okay, so now we want to figure out our probability of not A occurring. So let's figure out what A is first. So what's A? Between 1 and 40, what are our perfect squares? So let's list them. We have 1, so 1 times 1 is 1. 2 times 2 would be 4. That's a perfect square. 3 squared would be 9. 4 squared would be 16. 5 squared is 25. 6 squared is 36. 7 squared is 49, which is greater than 40, so that doesn't really, it's not included in our set. And now we know that number of elements in A is 6. 1, 2, 3, 4, 5, 6. Yep. And so what is our probability of A occurring would be, let's just recall the equation. So 6 out of 40 numbers, which reduces to 3 out of 20. So now how do we find your probability of not A? We could use that theorem that we talked about earlier, so 100%, or 1, minus your probability of A occurring would be not the probability of not A occurring. So that would be 1 minus 3 over 20. So here you would just find a common denominator, which would be 20 over 20 is 1, minus 3 over 20, and that would give you 17 over 20, which is 0.85 or 85%.